Faces. You have one and I have one. But what makes a face a face? In movies, video games, and in real life, we're able to decide which face looks real and which one doesn't. So how can we do that? As a social species, we evolved to recognize faces because it's our way of distinguishing ally from enemy. And it would make sense that those who are able to distinguish enemy are far more likely to pass on their genes to the next generation. And so our brains became hypersensitive to this sort of information. But our brains don't just process faces. They process something that's far more digestible, patterns. Our brains are always looking for something that can hint a face, like a big forehead or symmetry, or even a shadow under the nose. So this leads to a phenomenon called pareidolia, where we see faces on cars, on houses, on the Maria of the moon. It's a psychological occurrence that causes human brains to find facial features in random patterns. And it's easiest to see faces in cars, buildings, machines, and houses because of their symmetry. And so because our brains are always looking for faces, things that fit into the pattern are emphasized, and things that don't are discarded. Gaps are filled in, and our brain connects the dots. Now, there are two parts of the brain that are responsible for connecting the dots. The first is the temporal lobe, and then the second is the parietal lobe. So in the temporal lobe, we have something called the fusiform face area. It's part of the brain that analyzes patterns, primarily faces, but it doesn't have to be. You see, car enthusiasts, professional chess players, professional bird watchers activate that part of the brain when they're doing their craft. So our brain doesn't just respond to faces, it responds to patterns. It's just that faces are our brain's favorite pattern. So the same part of the brain is broken down into something we call face patches. And each of these face patches has neurons that are responsible for only one character trait that makes a face the pattern that we recognize. So to make a unique face, there's at least 50 different character traits. And unique combinations of these neurons in these patches are responsible for each of these individual traits. So researchers at Caltech actually took monkeys and they showed them pictures. And then by analyzing the different neuron combinations in the brains of these monkeys that were activated, they were able to basically recreate the face that the monkeys were looking at. So hopefully if this technology gets even more advanced, we'd be able to depict faces that witnesses saw without the need of any sketch artists or rudimentary software. And now the second part of the brain that processes faces is the amygdala. And that's the emotional part of the brain. It processes at 33 milliseconds, and so it's much faster than the way that we normally process visual information. But it's not as accurate. In fact, we're only able to distinguish friend from foe instead of details of who the person actually is. So now that we know how brains distinguish patterns and therefore faces, how do our brains know what makes a real face and a fake face? Because if we can see a face in something like this or this, then how do we know that it's not human? So actually, CGI developers may have an answer to that. Faces look realistic whenever they're too perfect. So whenever the skin is too smooth, the face is too lifeless, or the eyes are just too flat. And in video games, developers go above and beyond to make sure that faces have small imperfections and pores, and that the skin has an internal glow that is caused by light penetrating the skin and bouncing off at different angles. So in other words, every time we try to create a digital human, our subconscious is analyzing this image and detects the imperfections that make it look fake or the imperfections that makes it look real. But with stronger computers, realistic faces can be generated. None of the faces you see here are real. In fact, they were created by a network called the GAN, the Generative Adversarial Network. And the way it works is basically it has a database of actual faces, and it just takes characteristics from each face to create a new, unique face. But we just don't end in fake photography. Today we have even artificial AI influencers on social media. In Instagram, Lil Miquela has amassed up to 1.3 million followers. And she's not even real. So as we learn more about faces, we naturally get better at making realistic fake faces. But we also develop technologies that can identify real faces much better. Things that used to be in the movies are now becoming real life. So with classic old 2D facial recognition technology, you would just need to have two pictures side by side. They have to look almost identically the same. The face has to be looking the exact same way, and there could be no deviation from lighting. On the other hand, the new facial recognition software uses 3D modeling. And so it captures a real-time 3D image of a person's facial surface, and it uses distinctive features and landmarks of the face. So that would be anywhere where rigid tissue and bone is most apparent to identify the subject. So any award-winning facial recognition technology is using a lot of these landmarks, about 80 and up. And it looks at things like the distance between the eyes, the width of the nose, the depth of the eye socket, the shape of your cheekbones, and how chiseled your jawline is. And so we're using the combination of these measurements under the assumption that they don't change with age, that they stay pretty much constant. So using depth and other tools, we're able to model a subject's face in even poor lighting conditions, and the software can recognize its face even if it's rotated 90 degrees, aka a profile. So the facial recognition software scans your face on a sub-millimeter level, trying to get all the nooks and crannies of the face in order. And then it converts it to a unique code that it then compares to the database. But things get really crazy if you try to compare a 3D model of a face to a 2D image. And previously that couldn't be done, but now it can. And the way it's done is you would take the 3D model and you would take 3 reference points. So you can take something like the outside of the eye, the inside of the eye, and the tip of the nose. And then you would map that 3D image into a 2D image. And then you would compare the two. But to make that work, you need to have the 2D face be facing the camera at no more than at a 30-degree angle. So there's no doubt in my mind that future AI will become extremely good at making artificial, realistic human faces. And that technology now that we rely on identifying human faces is going to become much, much more accurate within a decade alone. But for millennia, we humans use our faces to identify friend from foe, man from animal. And as technology continues to develop, it begins to blur the line between man and machine. It's able to recognize faces. It's able to be a face. So what does that say about the survival of the very thing and things that make us human?